Hello. So this is the project demonstration for the Connect4 Embedded Systems project, Tier 3. And I'm just gonna start the demonstration. So I have the MSP430 connected here with the matrix display as the clock, latch, and data pins and the VCC and ground. It is. And as well, I have this little audio amplifier that is connected to pin 1.3. And from there I have the amplifier connected to a pair of headphones. And the point of this thing is that when a player wins the game, so out of 3 or 5 or whatever, it's customizable. When a player wins the game, a song plays. And this is a little voltage regulator I use for this is the LED showing it's on. This is the voltage regulator showing that it's on. And from there is this little power supply adapter thing. Just focus it. Anyways, so I don't have the buttons, so I'm actually just gonna have to do this. So first things first, let's get this out of the way. First things first, I'm just gonna do the vertical winning condition, because that's actually no, I'll do the horizontal winning condition first. So I'll just do it now. So 1, 2, and last one should be here. So okay. Nope, wrong one. This one. Hold on. Oh, there you go. So that was the horizontal winning condition, and just there said 0, 1, because the green player won. So just gonna go through the code here on the computer. So just gonna scroll down to the winning condition. Where are we? So this winning condition works by having an array. That's the array there. So 0f, 1e, 3c, and then has a for loop to go through each element of the array and checking if the columns of a certain if the bits of a row are the same as one of the array elements, then it returns a win. Victory equals 1. This is the return. Now, the reason for this is because let's see this thing. So you have to win horizontally you need 1 1 1 1 or 1 1 1 1 1. So like this. So 4 1s here, 4 1s here, 4 1s here, 4 1s here, or 4 1s here. And the row doesn't matter because it's all on the same row. So it translates to, F0, or 0F because backwards. So 0 or 0F, and then if you move by 1, you get 0 1 1 1, which is E, so 1 1 1 0, and then you have whatever 0 0 0 1, and that's 1E, and then you keep moving. So basically the 5 elements of the array are the 5 possible horizontal winning conditions, and of course the for loop just cycles through all of them. And if none of them are met, so if you have like only 3, so if you have 0E, that won't do anything because first of all it's not one of the conditions. 0F, 1E, 3C, 7, 8, F0. It's not one of the conditions, and so then it won't return victory equal 1. It'll just return 0. So nice. So next condition. So I'm gonna go to the vertical one. That's the next one. So that's how I do the vertical one. So 1, 2, 3, 4. And so the green will win again. So that's the green, so it says 0, 2. That's with the, I'll explain it later. So how the vertical wins thing is like this. So that's it there. Put it out there. So this is it. So you have if row is greater than or equal to 3. Now there's a reason for this, I'll explain it in a bit. So if row val mtx buff row of player, so this is saying the row and the player so the bits of a certain color. So you check the first one, and then you check the second one, but the problem is you have a -1 there. And if we look back at the matrix, again, since it's backwards, so you have this one here, -1 is actually this one here. And it's checking, is this one, a certain color? And is this one also a certain color? And actually it goes through -2 as well. So that's the one even above it, and then -3. So basically what it's doing is, it's checking for 0, -1, -2, -3, or in simple terms, the 4 on top of each other, the 4 sequential ones. And the reason for the if row is greater than or equal to 3 is because you can't win if it's over here or something. Yeah, so just the reason for the row is greater than or equal to 3 is because so let's say you're over here, you can't have 4 on top of each other at this point or this point or this point, because, well, it's not possible. So it's checking if you're here or lower, because as far as I'm concerned, it goes from 0 to 7, not from 0 to 7. It's backwards. So anyways, so that's the vertical win, and now the the diagonal win. So this one's just so let me just get it right here. So 1, sorry, did that work? 1, 2, and then 1, 2, 3. Okay, so 1, 2, 1, 2, 3. So that means 1, 1, 2. Sorry. 1, 2, 3. Oh, there you go. So you saw the thingy, and I was just an end screen. So you saw the game. It registered that when there were, where's the pointer thing? So when there were 1, 2, 3, 4, or 1, 2, 3, 4 in this case, these 4, it checked to see if it was a win. Now, we saw how in the vertical one, it was checking the one above it by deducting from the row. Now, it knows because you have the row and you have which bits are on or off. And then the vertical one, again, it was simple because all you had to do was deduct the row to see the ones behind it, or add, whatever you want. Then it's to see the ones behind it. But with the diagonal one, you have to move as well across. Now, since it's a linear pattern, you can actually apply the same rule as deducting the rows. So actually what you do is, you go back a row, but you also shift once. And then for this one, even further behind that, you go back 2 rows and shift twice. Go back 3 rows and shift 3 times. And that just happens to align 1, 2, 3, 4, the diagonal winning. And if we look at the actual code for it, you'll notice this is just one line of the few conditions. You'll notice that, again, what it does is row of player, and again, same like the one above it, row -1, but has the shifting. And then again, -2, and this one's also -2, but there's shifting involved. And again, -3 and -3 shifting. And that's basically how the code tells. So the thing is as well, if you have one over here and you go that way, the only difference is it'll shift the other way around, which I wrote that function as well. It just shifts to this way instead of this way. And as well, if you have, let's say, a diagonal, but the last one to be inserted is this one. This is a bit complicated, but I pulled it off. Actually, all you have to do is you add 1 and shift once to the left or whatever, or the right. I think it's the other way around. So anyways, you add 1 and then shift, but you also check if you deduct one and shift once, and deduct twice and shift twice. So you have these two in their own separate realm in the deductions, and this one in the additions. But yeah, anyways. So the next thing to show is actually going to be the I'm just going to pause the video just to set it up. Okay, so we're back here. Now the next thing I'm going to test out or demonstrate is the audio system I implemented. Now how this works is, I'll show the code first. So just going to scroll to the code wherever it is. Oh, so here we are. So there's a bit of music theory in this, so let me just bring the screen. So what you have here is you have a function called a tone gen, or tone generator, and it takes in the parameter of an integer called key. Now, how this works is you have, like on a regular piano keyboard, you have whatever number of keys, and what these keys all link to is a frequency. So this is 440, this is 466. They all have a frequency, and I think about around 16 keys or something. So 16 different notes, frequency notes. And what happens is, so you call them in this function. So let's say you want to play a song, so you select the correct keys, you put them in, you just put them sequentially, and then you call this function every time. And what it does is, so first it's a thing called note length, because the problem is that this frequency generator uses for loop delays. So it's on for a certain time, off for the same amount of time. But the problem is there's this duration. Now the duration, if kept the same, would actually have different times for each note, because the frequencies are based on delay. So a high frequency note would actually last less time than a low frequency note, just because the delay is longer in the low one. So how I fix that is that it uses the actual frequency as the final value for the for loop. So nice. And as well, for the actual duration of each note, it can be changed by changing this increment value. This is very confusing, but I eventually got it. And it returns nothing, of course. And it sets P1 direction, so port 1 of 08, what's that? Just the one pin. So just the one pin, P1.3. Set it on, set it off, keep looping, on, off, and then, return 0, finish. So I'll go to where it's actually called. Let's see, where is it called? Oh, here we are. So I have player 1 win and player 2 win, so I can tell which player wins or not. And as well, these values select out of how many rounds. So, if the game is out of 5 rounds, you just change these two values. I think, yeah. Yeah, I think these are them. And if you want out of 1 round, you just change them to 1. So what it does is, I'll explain this part later. But then it calls the functions. So -1, 1, 5, 8, 11, 8, whatever. So if player 1 wins, it plays a certain song. If player 2 wins, it plays a different song. And then just some other stuff. So I'm just going to pause the video and just do a quick demonstration. So here's an example of a piano keyboard. So how it works is, this is 1, 0, -1, -2. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever. So if you want to play a song, you do 1, 2, 3, 4, 5, 6, 7, 8. So 1, 5, 8, whatever. So anyways, that's just a simple idea. So okay, I connected the speaker because the headphones are too quiet, for obvious reasons. So I'm gonna I actually already played the game twice just to get 2 rounds in. So I'm gonna play the game a 3rd time. So if the camera can focus, just so I can see what I'm doing. So 1, 2, 3, 4, 5, 5, 6. Oh, flip. 1, 2. Okay, hold on. I'm actually gonna restart. Okay, and there's just some moving text, but I'll talk about it later. So 0, 0. So hold on. I'm actually gonna pause the video and get to the 3rd level. Okay, we're back, and so now I'm actually just going to touch the last pin once, and hopefully I connected the speaker correctly. It's not proper connection, I just pushed it in. So 3, 2, 1. So let's see. There you go. Play the song, and because the green player won, and then it restarted the game. That's cool. And the headphones work, but of course, again, we can't test them. But yes, that's the so the audio amplifier and the speaker system. And actually, I'll just play the song for when the other player wins, just, you know, since they're different. And now for the red player, just gonna, so 3 out of 3. Those and now it says, yeah, it says GG, which means good game. But again, it changes color depending on who won. So anyways, yeah, so that was pretty cool. And what's the last thing? Okay, so I guess I'll move on to now to the moving text. So when I restarted the game, actually I'll do the static text first. So I'll just restart the game now by shorting the thing. I don't know if that's good practice, but anyways. So yeah, so there you have the static text. Now, let's go to the function that calls it. So I'll move all the way up. So let's see. So that's the function there. Light LED it's called. Takes in 2 unsigned integers. So where is it actually called? Okay, there we are. Is it? Shucks. Yeah, so this is just for the first node. I want to see where is it. Where is it called to show the score? Where is the score? Oh, here it is, I think. Yeah, here we are. So what this does is it goes through every row and clears it of all colors. So red, green, blue, I think. So it clears all the colors. So it just sets them to 0x00. Well, it's not really setting. It just, you know, assigns it to that. And then you have a for loop which counts to 50. That displays the whatchamacallit. It displays the score. Okay, now this is how it works, yeah. So you have ID, and ID is hold on, just gonna pause.